Welcome to springlib.
The question tells us that the volume of air in the lungs of a runner are modeled by the equation V equals 400 times sine of 60 pi t plus 900. The volume is in centimeters cubed and the t is the time in minutes. And it asks us what is the minimum and maximum volumes of air and how many breaths does he take per minute. So I'm going to start with the first question. What are the minimum and maximum volumes of air? The minimum and maximum volumes, or the words minimum and maximum, hint that we are looking for the range of this function, since the range is the minimum and maximum of the function. So to find the range, we first need to find the amplitude and the vertical shift. So our amplitude is going to be 400, since it is this coefficient in front of the sine. And our vertical shift is going to be 900, since it is this constant added on to the end. So to find the range, range is basically minimum and maximum, as I said before. And since this is a sinusoid function, the way we find minimum is you take the vertical shift and subtract the amplitude. And to find the maximum, we add them together. So our minimum would be 900 minus 400, which gives us 500. And our maximum would be 900 plus 400, or 1,300. So now we have the range, but then we have to explain this in terms of the problem. So the minimum volume of air is going to be 500, and our units is cubic centimeters. And our maximum volume of air is going to be 1,300 cubic centimeters. So here are our answers for the first question. Now for the second question, it asks how many breaths does the runner take per minute? And to find out, we need to find the frequency, because the frequency is basically how many times the graph, or how many cycles the graph repeats in a given interval. And that's basically the frequency. That will answer this question. So to find the frequency, we first need to know the period, since frequency is equal to the reciprocal of the period. So period is given by this coefficient in front of the t. It's the 60 pi. And to find period, we would take 2 pi and divide it by this coefficient. However, we are looking for frequency here. And since the frequency is a reciprocal of this period, we could really just flip this fraction over. So frequency is going to equal 60 pi over 2 pi. And the pi's cancel, and we get 30. So now we have the solution. We actually have to answer this in terms of the question as well. And if we do so, we will get that the number of breaths per minute is going to be 30 breaths. And here's our answer to the second question. And now we've answered both of the questions, so now